In this video, we evaluate the integral from 1 over x times ln of x to the beta power from e to infinity. So here we're going to define beta to be a real number, and so we're going to consider different values of beta. But first, let's evaluate this integral. We're going to let u equal natural log of x, so du will be 1 over x dx. So I can rewrite this integral now as 1 over u to the beta power du. And let's evaluate these limits. Now these limits were in terms of x, so let's plug in x equals e in here, so u will be ln of e. So when x is e, u is ln of e, which is just 1. And then as x approaches infinity, ln of x will also approach infinity, so that means u will approach infinity, since u is equal to ln of x. And so I can rewrite this integral now from 1 to infinity, 1 over u to the beta du. Now I'm going to rewrite 1 over u to the beta as u to the negative beta power. And just for this one, I'm going to consider beta not being equal to 1. So later we're going to consider when beta is 1. Okay, so now this is an improper integral. So introduce a limit here and evaluate u to negative beta as u to the negative beta plus 1 over negative beta plus 1, going from 1 to r. Plug in r, subtract it, plug in 1. So so now we're going to say if beta is greater than 1, negative beta plus 1 will be less than 0. And so r to negative beta plus 1 over negative beta plus 1 is basically 1 over a negative number times r to a positive power. And we know that this is going to go to 0 as r goes to infinity. Okay, so we have 0 minus 1 minus beta plus 1 over negative beta plus 1. 0 goes away, and now I'm going to distribute this negative to the negative beta and the 1 to get 1 over beta minus 1 as my answer. Now I'm going to consider beta being less than 1. So now negative beta plus 1 is going to be positive. So this will be r to a positive number over a positive number, and this will definitely go to infinity. So we have infinity minus some constant here, and so this has to be infinity. Okay, finally we're going to consider when beta is equal to 1. So we want to go back to this integral, because now the integral is just 1 from infinity, 1 over u du, and introduce this limit here because, again, it's improper. Evaluate the integral to get ln of u, going from 1 to r. Plug in r, plug in 1. ln of 1 is just 0, so really we're just taking the limit as r approaches infinity of ln of r, and we know that's also infinity. And that's our answer.